So I'll go straight into the introduction, which is also a very quick drill down into the basic connecting to a Unix system. This presentation is done on Linux. I will be showing presentations that will give, some of them will be Linux, some of them will be Solaris. The workshops will also be done connecting to a Solaris system or a Linux system. You'll be able to experience both systems and the slight differences between them. They're very similar, but there's still some nuances and differences to be learned and to be familiarized with. So occasionally the presentations will be Linux, sometimes Solaris. This one, for instance, is Linux. What we'll be going over is logging on, doing basic tasks, describe the basic structure. I think that has to do with file system structure that we'll be going over. Editing files and managing the file system, which would be creating files, copying files, and so forth. We'll be going over all these issues in more detail later on in our course. Okay, this is Linux sites to access for if you need any more information. I use Google for most of my needs. There's Google and there's Google Groups. The two sites, and basically any kind of error message or problem that you encounter, if you spell it properly, or even if you don't spell it properly, it will correct you. Your spelling, it will give you hits on your issue. I use Groups more often. There's less sales and hype. When you go to the Google homepage, it gives you a lot of sales offers and price lists and things like that, and we're not really interested in that information. We're looking more for the technical side, which would be in Groups, which is the correspondence that people do amongst themselves in resolving problems. What's so special about Linux, or what makes Linux different? Linux is an open source operating system. One of the chatters that Linus Travelos, whatever his name is, has put on the product is that any code that is written for Linux can be free, with no charge, distributed on. If you want to make some kind of product to work on Linux, you have to add with it the source code of what you created. Nothing can be sold for money that is created for Linux. You can create your own products and sell them, but anything that's put out there, and there's a very large community of people that are freely creating drivers and improving this operating system at an incredible rate, which is in many respects even faster than Microsoft can deal with new hardware. The open source community, which supports Linux, is generating updates and drivers for devices out there as they come out, sometimes quicker than Microsoft can do for their operating system. So it's a very powerful operating system, and it's all in the spirit of friendship and camaraderie, which is something that we could do with in this role. Freely distributed, based on Unix. Linux is an implementation of Unix, which was designed in Bell Labs in the US. Is an operating system, System 4, System 5. It was developed originally for PCs, for Intel-based processors, but it also exists on different other platforms. It exists for Spark, which is the Solaris we will be showing later. It exists for PowerPC. It exists for many hardware platforms. Okay. Being developed by programmers all over the world, we went over that, and very popular Unix brand. Because it's on such a free and internet-based distribution, it's very easy to download the operating system. It's very easy to install. People just download it from the net and install it on their machines. The various distributions. One of the Red Hat is very popular. There's SUSE, there's Mandrake, and there are a dozen more that I can go, Yellow Dog and other. Some of them are more custom-tailored for a small footprint, which would mean a small operating system that can fit on a diskette, and give you the basic needs, and some are very large 3 or 5 CD distributions that include a very colorful distribution with office packages and development packages and compilers and various shell scripting languages, and it's very, very rich. Okay. These things more or less describe themselves. The years that things happened with Linux. Created by a student in Finland. He named the operating system after his, similar to his name, Linux. First public version, and releases. I did this, which is, we're talking about 10 years of development, and at this point, Linux is more or less a competitor for Microsoft Office. In these 10 years, Linux has moved from an operating system that is for gurus or people that are freaks or really want to mess around with creating stuff from scratch, which I remember installing it was you'd have to compile the kernel and do very, very tedious system operations in order to get a basic system installed. And once you had that, you didn't have connectivity to the internet or drivers for any peripherals. You'd also have to compile those, and things were very, very complicated. At this point, a basic installation of Linux will give you productivity Office equivalent to the Microsoft world, which is a very important thing, so you have a desktop that you can work with. That's the basic thing that comes, and most of the drivers you need for the hardware and peripherals that are out there today. And it has a graphical user interface installation, which is fully automated, which makes it an installation easy for the person who is not familiar with his hardware or needs. Okay. This is the login screen on GNOME. There are various window managers. Unlike Windows, which has one popular interface for it, a graphical interface, there's only one per se window manager for Windows. You have schemes. It's not exactly like window managers. This is the system on Linux or Unix is separated between a terminal-based character mode interface and a graphical user interface. These two different worlds are very, very distinct, and they give a very powerful environment for the developer or for a person to connect to the system. You can either work on using Telnet, which would be a character mode terminal, very basic, or use a protocol called X, which is interfaced by a window manager. That will give you a graphical interface. You have to be familiar with those two differences. We'll go over that in more detail later on, and we'll experience it in workshops. Usually on these screens you'll have this kind of screen, you'll have several options of different modes of connectivity to the system. It will usually give you an option to enter what's called a safe mode or a single user mode or a character-based mode. That will bring you to the character-based interface similar to a Telnet session. And if you log in here, you will get a graphical interface. And the graphical interfaces, there are many window managers. This is a sample of a window manager called GNOME. Another popular one is KDE. Solaris has CDE, Open Windows, and GNOME as well. The newest release of Solaris includes a variation of this same window manager. Any questions so far?
So, could you explain what is the GNOME exactly? I didn't understand. I mean, it's more than graphic interfaces.
Okay, it's actually
how does it impact
the menus, the toolbars, the whole display the whole graphical display is driven by the choice of your window manager. You have an application called Xserver. An Xserver is an application that you don't really talk with directly. It runs a window manager. Window manager is basically, will open a terminal, will give you like a backdrop, a toolbar, and drop-down menus, and the same for applications. The window manager variations is the way you perceive the menus and the shortcuts and basically the graphical layout, the little icons here, or the layout of this bar, the multiple workspace management, and other features that you have. All these are implemented in different ways on different window managers, which gives you a choice of what you want to work with. You have more variety. It complicates life because you have to be familiar with different types of interfaces, but it's more customable. You can customize it there are a lot of features, and the different GNOME and KDE have a lot of configuration that can be done, a lot of tweaking, and which makes it powerful. It makes it complicated, but it makes it powerful. CD is more basic and straightforward. There's not much you can do there, and you're stuck with what you have. Support for multimedia and applications is better on GNOME and KDE. Solaris CD is not so great on multimedia. And of course, what you will see here on the menu is a function of what you chose when you installed the operating system. If you'll have OpenOffice or different tools, if they'll exist here on the menu, this is a function of if you chose them when you install the system.
One more question. There's, as you said, this is an open code, and since it seems sometimes that this is the way that somebody writes a new interface for it. How do we know, as a company or as a private person, is this version stable? Did it go through all the different testing? How does Solaris decide that GNOME is now stable enough to put on their systems? If we decide to go with something like this in our systems, it seems, I don't know, if you take Microsoft, they do have their only one option, but it goes through a set of testing.
In the open source world, there's also a beta level and a version management system for the releases of all the applications, including Windows managers and all the applications. Everything that's created for this environment is done with strict and very rigorous testing systems, which include version control that will document in the version level of each product at what stage it is. If it's in beta, it's alpha, beta, and so forth, just like we're used to doing in our applications in the software world. So, for instance, Solaris, when in version 9, or even version 8, they started putting out GNOME as a beta release for their version 8 of Solaris. Later on, they released it in 9, and now in 10 it's stable. You have a choice of adding it to your system in the same way on Linux. You can add, it's even easier in many ways on a Linux system because there's a much larger community of people who write applications for Linux than there is for Solaris. And they use environments. There are many sites on the internet where you can download either source code or precompiled binaries of applications, and they will register their level of maturity as far as, usually if I remember correctly, odd numbers of versions for kernel and other applications. Odd numbers are not stable. Even numbers are stable. So if you stay with even numbers, you'll be more stable. I think that's more or less. They use very similar systems to what we use running our applications, and everything is documented. The maturity of products is documented on all the applications and even the window managers and other more complex applications. Okay, server desktop environment available GNOME and KDE. We went over that. X window compatible. We went over that as well. Drag and drop compatible. That everybody's familiar with that feature. It exists in every modern graphical user interface. Easily customized. We went over that also. Okay. This varies from window manager to window manager. We'll be doing it on our workshops. You'll be accessing the various systems, the Linux and the Solaris, and we will show, I think, KDE, GNOME, and CDE, at least those three will be showing. So you have background, a browser, a terminal, a menu, shortcuts on the desktop, and virtual window manager. This will give you virtual desktops. So when you click on this box, you'll get a blank, similar thing, and you can move between these four. You can also customize it to have more than 4 desktops. You can name them and so forth. Here you'll see minimized windows, very similar to what you're familiar with. As window managers or graphical user interfaces evolve, they basically all end up doing very similar stuff. Things are not so different, so they're pretty intuitive. The menu, which is a pull-up with the different, let's say, folders, and under the folders you'll have specific entries. This will give you your last choices. Things that you chose last will accumulate up to a few numbers over here of what you chose. All these things are configurable. Okay, what's an operating system? Or this is it's not only Unix, but almost every operating system works in this hierarchy. We'll start from the bottom. You have hardware. The hardware has 3 elements. You have a file system, which exists on your hard drive or on different devices, which includes a kernel, which is in the process of booting a machine, will be loaded to memory, which is the manager of other processes. Basically runs, it schedules, it runs your applications. That's the kernel, that's the essence of the operating system. So we have a file system, which is the sticky or the existent, the stuff that stays when you turn off the machine. You have the kernel, which is read from it at the boot process, which runs the processes. One of the processes, or the interface for applications and for us to communicate with, is the shell. And under the shell, the various shells that exist will run our applications. Okay, this is a different layout presentation of it, more specific about the kernel. We're here, just in case somebody was lost. We'll interface with the shell, which in turn will access the kernel and ask it to do services for it. We'll put an input, and as a result, we'll get an output. The different shells that are K-shell, C-shell. C-shell is, okay. We start with Bourne shell, which is SH, which is the most basic shell that existed on any Unix. It exists on all of them, and everything was developed from that. People started making more friendly or different variations. They add all of them. So on the basic SH, which is the basic Bourne shell, we have K shell, C shell, we have TC shell, which is a turbo C shell. We have Bash. Bash is Bourne again shell, which is a variation on the shell. And this is our prompt, and this is where we'll write our shell scripts. We'll go over that later in our course. Okay, process. Our keyboard will give input. We'll type in some kind of string of characters. We'll hit the enter. That will go to a process. We'll run a process. The process has 2 ways of giving out output. output would be standard output, which would usually be to our display or console, and standard error. Standard error is something goes wrong, the output will go to standard error. We'll show that also examples and workshop it also later. File system. Tree-structured file system. It's similar in many ways to what we're familiar with from Windows or DOS. The root file system is presented by the /, which would be the highest level of the file system. Everything, all the files and directories are children of the root file system, which is a distinctly different structure than what we're familiar with DOS. DOS has letters to represent partitions or physical disks. In Unix, the file system is more flexible in the manner that you're not limited to 26 letters or however many letters you have in your language to represent devices or file systems. Physical disks and physical partitions on disks are mounted under the root file system. Everything is mounted in which will create you a unified file system, which you will lose your physical entities in the file system, which makes it more of a unified thing from devices that are different. It gives you a possibility, a flexibility that doesn't exist with the C, D, E type of structure you have in the Windows system. Okay, most popular or common directories, sometimes file systems. We will go over that later, and I will show you how the differences of how to distinguish if you have just a file system, a directory, a device, partition, and so forth. But you'll find bin, secure bin, that's what SBIN stands for, secure bin. There was a time that they still maintain it in most strands of Unix, that the more powerful binaries that will control devices and processes that need to be more secure, those binaries will be stored in SBIN. For instance, route or ifconfig, which are binaries that will handle the networking. Since we don't want somebody hacking into our network and controlling our system, they will be located in secure bin. And with that distinction between safe binaries and non-required security or safety binaries in different directories, you can apply different policies of security. Like not give a path, don't put this in user's path. If SBIN is not in the user's path, if he's not familiar to look there, he won't be able to run these applications. Or you can use more secure measures to control the binaries. Later, some versions, for instance, Solaris, I think they even linked them. So it's really, they've lost that distinction in many ways. Home, which is the tree of home directories for users. USR is a little bit confusing. USR is what the system uses. Usually it's like the binaries that exist on the machine itself. It's the operating system binaries, basically. That's USR. OPT is applications that you pay money for, basically. If you buy products, usually they'll install themselves under OPT options. That's what it stands for. Temp is a swap. It's actually a different file system. It's your swap file system. And under home, groups, or users, whatever. We'll go over users and groups later on with permissions and files. No, not so far. We have an example. Okay, we opened a terminal, and we'll go over this more in detail, but basically we did an LS, which is the equivalent of dir in DOS or Windows, or dir, or opening, browsing a file system. We'll go over the switches, which is a way to give program information, we want variations on its abilities. Modifiers, okay, that's a good way to put it. Modifiers. If we want to modify the behavior of the, ls is a binary. If we want to modify its behavior, we'll give it a switch, which is usually preceded with a dash and a few letters which represent the different modifications we want to apply onto the binary. The application, the ls application will read these, read this information into its process and give us a different output according to the switches that we choose. We also give it qualifiers, which would be a way of filtering out part of the output. We'll go over that in more detail later. I'll just go over this briefly. These are permissions and other information, dates, and so forth for files that exist in a directory. We'll go over the directory structure in more detail later on in our course. Commands. Okay, the most basically used command would be ls to see where we're at, what the files are, and so forth. Who will list who are the users on this machine, who's connected, who's logged in, who's using which terminals, and what they're even running, what application they're running. PS is process listing, will show us information on what processes are running on the machine we're connected to. The switches on PS vary. The most commonly used one on Solaris is -EF. On Linux it would be AUX. We can go over those switches later. They're also, you have to note that the matter of having a dash or not having a dash can vary from program to program. Most programs use the dash to represent the switches. There are few exceptions like tar and PS on Linux, which will also, you're most likely to not use dashes in the switches. I think those are the most common exceptions that would come to mind. But we'll go over that also in detail. Okay, pipes and filters is a little bit advanced for this step, but we'll give the concept in general. We also went over it a little bit. There's the matter of standard input and standard output. If you have two binaries, two applications, and you want to transfer the standard output of one application to the other application, you will use what's called a pipe. Pipe is represented by this character. So most programs, Unix binaries behave as filters. That means that they are able to receive standard input through a pipe and to give standard output into another pipe. It means that they can behave as pipes or filters. It's a similar thing. We'll also show examples and practice how to use this thing. It's a very powerful ability. It exists in a very basic way in DOS or the command line of Windows. In shell scripting and in Unix shells in general, it's a very, very powerful tool that it's very handy to be familiar with. We have an example here. We want to take the output of PS and we want to pipe it or feed it into the grep, which is another utility. Grep, what it does for us is it will search for a string sequence in a file or in standard input. We're running this command, which will give us the previous listing that we saw. The whole listing is piped into grep, which looks for the string sequence of group. Want to share? Okay. This is another example, a more compound one. It will take the the output of the grep command, and it will count the amount of lines. This is word count. WC stands for word count. Minus L stands for number of lines. So this will give us a numbered listing of how many entries in the output of PS minus EF include the string of group 1 in them. So if you have 10 listings or 10 lines in the PS, you have 10 processes, for instance, which are 10 lines, which all, out of them 4 have the string group 1 in them. The output of this command would be 4. We'll count this thing for us. It's very useful. I use it in shell scripting. Okay, list files, mnemonic list. Oh, minus L is like log, gives a lot of information. LS, without any switches, will give us just the names of the files and the directories. The minus L stands for log. We had an A before, the A stands for all. All would include files that are hidden, which start with a dot. We'll go over that later. File command names with a few characters. Important tips. Double escape. Arrows. Okay. This is shell behavior, and it's not exactly specific. These things vary from shell to shell. The different ways of the shell that we discussed, the different shells. The TC shell, there's C shell, there's bash, and there's shell. The keys, the keyboard keys behavior in the various shells changes. Sometimes the arrow keys give you your previous history command. The up and down will give you previous history, and sometimes they don't. Sometimes when you use the tab, you will get a completion of the directory. Sometimes you use escape to do the same thing. All these things are different behaviors of different shells. If you want to be familiar with them, you have to learn the different shells and their behaviors. In most cases, you can configure the shells to do similar stuff or what you need, or you can basically use your favorite shell and get used to it and learn its language, so to speak, so things will do what you want. Control C is interrupt any kind of process. We'll go over the interrupt options, backgrounding processes, and so forth. Okay, short review of the basic things. LS minus long information and all, including hidden files. If you want, again, hidden files are files or directories that start with the period character. So if you want to see those, you'll use the A. If you don't want to see them, there are a lot of them. Many settings are stored in dot files. So you don't really need to see them on your basic listing, so that's why they're hidden. So this is your way of either choosing to view it or not view it. Move is, in Unix, is MV. And copy, basic manipulation of files. RM is delete, or del, what we're familiar with in Windows.
So, back to the move.
Yeah.
Can you move any file from any directory to any directory using this command?
Okay, move has an option switch called -R. It's not recommended. It varies, its behavior of that command usually does what you want. But it varies from system to system on how it copies the files and if it includes everything. And the file system is not as basic as just files and directories. In Unix, you also have links, hard links, and variations on objects in your file system. Therefore, when you use move -R or -R to copy a structure from one location to another, you are not sure that you will have an identical copy in the destination if you use the MV -R. It varies and needs to be verified if you want to make sure. There are other ways of copying.
Can you stay in a directory in lower hierarchy than the directory you would like to move to, and use this command, move?
Yes, you can.
You can,
You can be in a different location in the tree and perform the safest
to
way.
indicate that there's no need to indicate the path for approaching the file? Directory I mean, if you don't stay at the specific directory you want to copy the file or move the file from,
Okay, there are two
or
basic-
hierarchy.
Okay, there's relative paths and complete paths or full paths. If you use full paths, you're safe. If you use relative paths, you have to verify that you're using proper relative paths, and it's tricky. Therefore, you have to be more experienced into knowing what you're moving to one place. Things can be very destructive when you move stuff around. It doesn't warn you. You can configure it to warn you and do things interactively, but usually if you're transferring a lot of information, you don't want to be interactively prompted for every type of override or things like that. So you have to learn to use these commands safely. I don't use move at all. Very rarely I'll use move. I use tar for copying structures from one location to another. It's just a matter of habit. It's more complicated, but it's always there. And so far it's proven itself, and I never went into researching how move behaves because it's not trustworthy in different systems. So I just never tried. And the same thing is with copy. Same thing. For single files, only for single files, I use move or copy. Any structure bigger than a single file, or for moving a directory. Again, there's another distinction that you have to pay attention to when you're moving a directory from one location in a mount point or in a file system to the same file system. It will be very quick. When you're moving it, you may not be aware that you're moving it to a different file system, and it will take more time, or you'll run out of space and other kinds of things. It's not, since we described the structure of the file system, it's very, very loose. You're not really sure where you are. You can be moving it from one physical disk to another physical disk by moving it from one directory to another, and you won't even be aware of it because you don't know the underlying structure of the hardware. It's not like on Windows, when you're moving from C to D or from D to E, it's very clear to you that you're moving it to a different physical device or file system or network or whatever. Here, it can be very transparent. Okay, remove, which will remove files. Touch will create an empty file, if we want to create an empty file, or we want to change the timestamp on an existing file. It's another use for it. We want to bring it up to date, so the timestamp will be current. We'll use touch on an existing file. More is to print the contents of a file by type in dots. Okay, what do we have here? We have examples for ls, copy and move. These are wildcards, qualifiers. We'll go over the different wildcards, but in many they resemble what people are familiar with DOS. This will give us a listing of all the files that start with job2 dot. Full listing, including hidden files of 0. This is a little bit redundant. The A is redundant here because we're qualifying only file names that don't have dots in them, so it's a little bit redundant. But it's an example of being redundant. Okay, more of a text file. We're typing the contents of a text file, which happens to have this line in it. Okay, basic directory commands. CD is change directory. If it's entered without any arguments, it will bring us to our home directory, whatever is set as our home directory. Make dir is creating a directory. Remove dir is removing a directory. If a directory is not empty, it will not agree to remove it. To remove a directory, we do an rm minus r. If we wanted to force it, we do a minus rf. Good working directory will show us the current directory where we're at in the tree. Okay, examples for CD. CD without anything will just bring us to our home directory. The $sign is usually a representation of a user prompt. A pound sign usually represents the root user. So that's a way to distinguish. In most cases, it can be forged. So you can be root and have you can change your prompt to something else. It's just the convention is that a is usually a user which is not root, which is not as powerful and cannot do everything that root can. Root can do everything. Obviously, those are usernames that we log in to the system. Remove a directory. As we stated before, if a directory isn't empty, it will not include it. Process listing. There are various levels of detailed or the processes we can filter out to have only our processes or a complete listing of all the processes on the system. F, I think, stands for full. I think E stands for like everything or as much information. Okay, shells and processes. This is an example of filtering out the shell, which processes are born-again shells. So we do a listing of the processes and we pipe it into the grep utility and look for the string called dash, and we'll get a listing of the entries that show this. Now, this is a phantom. You can ignore this line. We only have one bash. This is the grep process that we ran here. Okay? So this line is actually bogus. It existed only during only during the time that we ran this command. After that, it exited, but we still get a listing.
So could you please explain again the meaning of process minus CF, what this modifier stands for, and pipe them to grep bash?
Okay. PS is like the task manager in Windows. We'll give you a listing of all the processes that are running on the system. Now, you give it a qualifier of EF, we'll give a more verbose listing of more information, and a full listing as far as categorizing. You can have different categories, users, groups, or you can tell the process listing to filter out and give you different groups. When you want a full listing, you use the F. So those are that's the PS. Now this output will feed into the grep command, and we're telling the grep command from the output that you just received, find me which lines in that output have the string bash, and print them out. And as a result, this whole line will give us the bash processes, a listing of the bash processes.
The string bash within the name of the file, or
within the output,
anywhere through the file?
Not file. The output of this command. The output of this command. You imagine that we ran two processes.
The output of this command is list of processes.
Right, which looks like this, and more processes. There are a lot of processes on the system, but we only want a listing of the processes that have the string bash in them. So we tell grep, just get rid of everything and give us just the ones that have bash in them. So that's what this command will do. This is a very, very common sequence. We use it all the time. PS minus EF will give us all the processes on the machine. But we're looking for information. We want to know what's happening with a specific process. We want to know if it's there or it's not. So instead of going over the list, which is very tedious, we'll tell it, find me the process that I want, just give me a listing of that one. That's the way to do it. Editing files. Okay, editing files. We have samples here of a graphical editor. We will go over the two various types of, the two important types of editing. You have either a graphical interface, which is an editor which we're familiar with, a notepad or variations, pull down menus, you know, the standard thing, there's not much to go over, or we'll also go into VI, which is unfortunately not a friendly editor, but it exists on all Unix systems, and in many cases our Windows system fails to come up, or it doesn't exist, or there may be many reasons why we are unable to open a graphical type of editor. So if we have a different one like Pico, or there are variations on the editors, then wonderful, but you can be sure that VI on every system exists, and therefore it is a very basic necessity to be familiar with at least some basic editing skills in VI, even though it's not so friendly.
Linux is not superior to VI?
It is, it definitely is, but it's not always there. You don't always have Windows. You don't always have you may not be on the machine itself, you may be on a remote machine. When you're on a remote machine, you may not be able to transfer the display, which is something we'll discuss later, how to transfer a display, which is very powerful, but it may not be available because the protocol is blocked or many other reasons. You may end up being in the terminal telnet type of environment, and in that place, you have Emacs as opposed to Emacs. You may want to use that if it's there, but if it's not there, and on most systems that are not designed to give a development environment, you won't find Emacs or Emacs. They just don't exist. This is a sample of gedit, which is the GNOME notepad, so to speak. Right? Windows has notepad. GNOME window manager includes a basic editor called gedit. It's just, you know, a basic editor. I think there's no need to really describe how to handle it. It's straightforward. Not important. Okay, other editors. We discussed this is probably the X version. There's an X version and a terminal version for the editor. The question is, if you're working in Telnet, this thing won't run. If you're working in GNOME Window Manager, you'll get more powerful, colorful menus if you use this one. If you use the one without the X, same like this in Emacs or Emacs, you get a variation of how the implementation of the menus is done, if they're done with the window manager or they're done with a character-based keyboard interface. Emacs, Joe, Jed, and so forth. There are many, many editors for, they basically all do the same thing, and they're usually straightforward. Okay, printing files. Printing is a little bit more of a hassle in the Linux environment. The configuration of printers is getting better. It's not at the same level as it exists in the Windows world, but we may have time to go over that later, I'm not sure. The basic commands, if something exists, if a printer exists and is pre-configured and exists on the machine, usually LPR minus a large or capital P in the name of the printer and the name of the file will print it out for us. If a printer is not configured on the machine, you're better off speaking with somebody who's familiar with how to deal with printers at the site than trying to figure out how to deal with it. So this is an example of how to print the file etc hosts to the printer called Brother56. To ask the printer manager what's the status or what's on the queue of a specific printer. LPQ, capital P. And the name of the printer will give us a listing of the queue waiting to be printed on the specific printer. Print files. Okay, we have LPQ, capital P, name of our brother printer. Our brother has no entries. We run the print command of a file. We run the LPQ command again, and we get a listing of our entry being printed. If everything is okay, we run the command again. You'll have no entries, and most likely your file has been printed. How to compile and run test programs. We'll go over this briefly. It's not exactly in the scope, but sometimes it's useful. The example is Fortran. How to compile, but it's very similar to using C. Solaris machines don't come with a built-in compiler. Most Linux distributions include a GNU compiler with them. Okay. You write a Fortran program. This is a Fortran program. You write a C program, it doesn't matter. You run the binary for your compiler. It would be a small cc for C and a large cc for C++. The name of the file. The default of the compiler is to create a file called a.out, which is the binary it generates from compiling your source code. You can change that by using the -O option to change the output from a.out to whatever name you want. So that would be an example of how to print hello world in Fortran. Pretty straightforward. What is this difference component? I don't know. Oh. I think it's another listing of the same thing. I don't see any variation here. Oh, this is the variation, the -O switch. Finding help. Online help for Unix machines is MAN, which is short for manual. There's also apropos. I don't know if they show it here. Okay, maneuvering within the MAN utility. MAN is a utility. You run MAN and the name of, type MAN and the name of the command you want the manual page to be presented on. And once you're in that, it scrolls down, and these are the maneuvering keys within that utility. You can move back and forth. You can search for strings with a slash, and Q would be a quit. So I have space, or page up, page down usually works also. Okay, this is a sample of MAN-LS. This is the way it's presented to you. Okay, the structure of a MAN page is very specific. You have switches in alphabetical sequence. You have the general description of it on the top, and you have optionals and squigglies. There's a whole structure of how a MAN page is used. You can go over that in detail later, whenever there's time. Okay, summary is very short today. I didn't give you a lot of time for questions, so I'm not sure where we're at as far as time, but if you have any questions at this point, I can answer.
Do we have a compiler on the Solaris that we have?
The machines do not include compilers. Compilers for Solaris, there's GCC for Solaris also. We have it installed on the corporate network, a networked device, and it's mapped to all the machines on the network. That's a service that we provide internally. Basic Solaris distribution does not include any compiler. Sun's compiler is purchased. You buy it and you can add it. We don't install it on the machine. If you need a compiler, you can either use
that script or something to run the system. system, so we would have to compile it outside. And just,
Well, script does not include compilation.
There's no need for
Script languages, whichever variation on them, require either the shell for shell scripting or something like Perl or Python, which will be like an interpreter that would run scripts for us. So if, Sun includes Perl in it, for instance, as a scripting language. It's included in the distribution, and you can add it as a package to an existing system. C is not on Solaris. On Linux, you have everything. Linux distribution includes the GNU compiler. It comes with a system. It's it's fully integrated.
and the debugger also.
Yes, there's DDD. It's not so great, but it's there. It exists, and they improve it as time passes.